Hello everyone, happy to see you here, welcome back to my channel Higher Mathematics, and today we have a really interesting challenge. A cube plus a equal to 350, and we need to find our a from this really interesting challenge. How can I do this? First of all, let's bring this constant from right hand side to left hand side. So what do we have right here? We have a cube on the left side, a cube plus a, and we bring this 350 from right to left. So we have minus 350, which is equal to 0. This is our first step. Second step, let's express this 350 as 343 plus 7. Let's do this. So right here we have the same beginning. So we have a cube plus a, and we have minus, but instead of this 350, let's write this expression 343 and plus 7. Yeah, we can do this like that. This is absolutely the same expression. So this 343 plus 7 is the same as 350, so it changed nothing. But it helps us a lot, because right now let's group this. First of all, let's open these parentheses. So what do we have right here? A cube plus a. Because of this minus, we change this sign right here. So we have minus 343 and minus 7, which is equal to 0. Okay, this is our expression. Right now, let's change position a little bit. So let's try to group this a cube and this 343, and let's group this a with this 7. Okay, let's do this. So right now we can easily do this. We have, what do we have right here? We have a cube minus 343. As I told before, we group these two expressions, 343, and we have plus a minus 7. So plus a and minus 7 equal to 0. Okay, this is our expression that we really need right now. But if you look closely, 343 we can write as 7 cube. Okay, so 343 is the same as 7 cube. Okay, 7 times 7 times 7, you can easily check this expression. Yeah, we have absolutely correct expression. So 343 equal to 7 cube. So right now let's change this 343 as 7 cube. So what do we have right here? A cube minus 7 cube plus a and minus 7 equal to 0. Right now we can easily take this expression inside parentheses, because we have addition right here. So it changed nothing for us. Right here parentheses and right here parentheses. But let's look at this expression right here. So we have a cube minus 7 cube. Saying in other words, we have difference of cubes. So let's remember a formula right here. So a cube minus b cube. Okay, let's remember our formula, which is equal to, okay, so we have a minus b in first parentheses, and in the second parenthesis we have all the time plus. So we have a square plus b square and plus ab. Okay, this is our formula. We really need this formula right here, so we are going to apply this formula right here. Difference of cubes we can apply right here. So instead of a we plug in a, but instead of b we plug in 7, so it's really great. So let's do this. So a minus b, so a minus 7 right here, so a minus 7, and inside second parenthesis we have a square plus b square plus ab, so we have a square plus 7 square plus 49, and plus ab plus 7a, and we have plus a minus 7, so we still have this expression, plus a minus 7 equal to 0. Okay, right now if you look closely, we have absolutely the same expressions. We have the same expression right here and the same expression right here. So we can easily factor these expressions. Let's do this. So a minus 7, let's factor it. So we have a minus 7 inside parentheses, and inside another parenthesis we have this expression plus 1 from here. So we have a square plus 49 plus 7a and plus 1 from here, plus 1 from here, which is equal to 0. Right now let's simplify this a little bit. We can add 49 and 1 from here, so as a result we have a final expression. We have a minus 7 right here, a minus 7, and in another parenthesis we have a square. Let's change order a little bit. Let's write it in case of quadratic equation, a square plus 7a from here, so plus 7a, and plus right here we have 49 plus 1, we have 50. Okay, so we factor our challenge. We have two parentheses, and in terms of math we need to know that if we have two parentheses, if a product of two parentheses equal to 0, so it implies that one parenthesis equal to 0 or another parenthesis equal to 0. Let's look, for example, at this first parenthesis. So let's write the equation with this first parenthesis. So what do we have right here? A square plus 7a plus 50 equal to 0. This is a classic quadratic equation. Everyone should know a formula. For example, this is a general case right here, ax squared plus bx and plus c. This is our general case, which is equal to 0. So for this general case, we can also write our solution that x equal to minus b plus minus square root of b squared minus 4ac, and all over 2a. This is our general case right here. So let's plug in all of these a, b, and c into this spot right here. So in our case, a equal to 1, b equal to 7, b equal to 7, and c equal to 50. So let's plug in each of these coefficient into our expression right here. So what do we have right here? But in our case, we work with a right here. So let's work with a. In our case, not x but a. So we have right here a equal to what do we have? Minus 7 minus b plus minus square root of b squared minus 4ac. So we have 7 squared minus 4 times 1 times 50. Sorry, and all over 2a, which is equal to 2. Okay, let's simplify this a little bit. So this is equal to, so a equal to right here. So what do we have right here? Minus 7 plus minus. Right here, what do we have? 49 minus 200. What do we have right here? Square root of minus 151. And all over 2. Right here we have a negative square root, so it implies that right here we have complex root. And let's write this complex unit. So what do we have? Minus 7 plus minus square root of minus 1 times square root of 151. Okay, and right here we have our complex unit all over 2. So that, as a result, we can write our root right here, which is equal to, we have minus 7 plus minus square root of 151 times I, and all over 2. So right here we have 2 roots, and right here we have 1 root, and let's find this root. So from here a minus 7 equal to 0, and from here a minus 7 equal to 0, and a equal to 7. This is our a first, and right here we have a second right here and a third. So let's write our answer. Let's write our answer right here. So our answer, let's write our answer. a first equal to 7. This is real number root right here. A second, this is our first complex root. Let's work with this plus sign. So we have minus 7 plus square root of 151i, square root 151i all over 2. This is our second root. And absolutely the same, but with the minus sign, we have the third root. So a third equal to minus 7 minus square root 151i, and all over 2. This is our solution to our challenge. This is our complex root right here, and this is our complex root. So this is our general answer to this challenge. So as you can see, we find all roots to our challenge. And let's check it real quick. Let's check, for example, our 7, because it's really hard to check our complex root. Let's check, for example, our real number root. So let's check it. What do we have in the beginning? We have a cube plus a equal to 350. From here, if a equal to 7, so a equal to 7, so what do we have right here? 7 cube plus, right here we have 7, equal to 350, which is absolutely correct expression, because this is equal to 343 plus 7, which is equal to 350. So this is a correct root for us in real number roots. So this is my explanation to this challenge. I hope you understand this explanation. I try to explain it slowly, step by step. Maybe this is the easy equation for a lot of students, but I wanted you to look at this step-by-step explanation. So as you can see, we can easily go through the steps real quick. So first of all, this trick will help us a lot, because right now we can write it as difference of cubes right here. It helps us a lot to write this 343 as 7 cube. Next step, cubic formula right here, and we can easily factor our challenge. So this looks like our first step to factor this expression as a product of 2 parentheses. So it helps us a lot. And right now, this parenthesis equal to 0, and the second parenthesis equal to 0, but in the second case we have our complex root, because our discriminant is negative. this is our full solution to this challenge. There is no more roots right here, no fourth root, no fifth roots, only 3 roots, 2 complex root and 1 real number root. Real number 7 and 2 complex root. As you can see, this root works right here really great because it's the correct expression. So thank you for your time. Have a great day. Also write your suggestion down into the comment section. What do you think about this solution? Maybe you have another solution, because cubic equations have a lot of approaches. Every student can solve this in their own way. A lot of approaches, a lot of methods. How can we do this? This is my method, and I want to share with you with this explanation. I hope you understand it. I hope you learned something new, but definitely don't feel bad if you got this wrong. Thank you for your time. Thank you for your support. See you in the next videos, and have a great day.